Okay, hello. So in this video we're going to go through how to write command files to do observations. In particular, we'll look at an observation of the sun. So we'll see how to write the files, how to get them onto the SRT control computer and execute them, and then get the data files back. Alright, so let's go through the process as I would basically do it. Alright, so here we are. This is where we finished at the end of the last video. We have the telescope observing the sun. Let's go and have a look on the camera. Okay, we've got the usual flicker. There we can see the telescope's observing the sun. We've still got the pointing correction set, although maybe that needs updating since we're now looking at a different position. So I'd normally do a pointing correction when I first start observations, and then if I go to a different source sometime later or a bit different part of the sky, I might want to do another pointing check, but hopefully we'll find the pointing won't be too far out, and so we don't have to worry too much about that. So we've done an endpoint and we're observing the source, but we might want to do a bit more than just sit here collecting data. Here's the accumulated spectrum. Look, I will say there is a bit of a glitch in the software at the moment, because actually up here it tells you the total amount of time that data is accumulated, and that can be interesting, somewhat useful, although it's a little difficult to interpret in terms of these integration periods. Of course, in the data, in the data file, what you'll end up with will be a table of data. And remember, this plot here is essentially just the plot corresponding to that part of the spectrum with this amplitude subtracted, so to speak. And you'll always, in the end, not be using these graphs, but actually using the data in the file. But we can see a bit of text is cut off at the top there. I'll look into getting that sorted out, but it's not critical. There's nothing critical there that's really not showing up correctly. So let's suppose now we actually, for instance, you're given a challenge in the sort of learning task, and it's a useful one in the project manual, of doing a scan across the sun, and from which you can measure the full width half maximum beam width. So how do we instruct the telescope to do that? In fact, we could do that sort of scan manually using this offset button and the record button, but it's certainly simpler to use a command file just to control the whole thing, plan it and control it, and certainly that would be the case when you're doing observations of the galaxy. So let's see how we do that. You can go to the project manual. There is a copy sitting down there on the desktop of the SRT computer if you ever want to have a look. And note that there's this file transfer feature up here. So if you wanted to go and get a copy of that, actually let's see how we'll do that. So we'll say let's do a file transfer, and let's say we want to go to we want to find this file over here on the remote computer. So where is this located? Well, it's going to be in this Unix directory home/srt/, and then I think from memory, I've looked at this for a while, there'll be a desktop folder, and there we have the file. So we can say now, let's go and receive that file, and let's just go and put that on my desktop on this computer. So let's receive that file, and it'll copy it straight across. And of course it's available on LMS, and you've probably already got a copy sitting right in front of you. But just if you're there at a given time, without one, it's available. Alright, and we can see it's now on my desktop. This is just showing what it's done. And close that. If I just minimize that window for a minute, there it is. Now, if we look through this manual, and you will need to read through this, appropriate parts of it, but let's in particular go to the part where it gives an illustration of a command file to observe the sun. And let's just copy this now. So there are various ways you can proceed. If you want to write a command file, you could write it directly into a file on the SRT, but sometimes the internet connection to the SRT is a bit slow. But if you wanted to do that, you can, and copy and paste should themselves work. So, oops. And the way to access, to edit one of those files is to use this text editor. The text editor is known as gedit. That's how I pronounce it. And let's just pop it in. So we could actually, I've just copied those commands, we could actually just copy and paste. And it says, TeamViewer has detected keyboard shortcut. To forward shortcuts to remote computers, please activate the menu item, actions, send key combinations. Yes, I do. So what I want to do now, even if we didn't use the shortcut, and it probably wouldn't make sense because I'm using a Mac with Command V rather than what this Linux computer wants, which is paste with Control V. So, so that's spectacularly not worked. Let's say, did I copy that? Copy it. And whenever you put your mouse up here, the menu items for this window that the cursor is in appear, which is this text edit. So edit. Let's try again. Paste. Okay. That should work. Anyhow, so there are various ways to proceed. We actually need to be working with a plain text file. We could do this in Mathematica. There's a handy thing in Mathematica that if we put in and I'm just going to use this as a scrapbook, in a sense, to do a bit of composing before I copy it over. So I could open a code cell and then paste what I've got, and you'll immediately see that it's highlighted in different colors, and this is just helpful for the eye to be able to read and pick out the different aspects. So let's have a look at this. It says, the first line says, this line is just a comment, it does nothing. That's right, any line that begins with an asterisk is treated by the program that runs this command file as a comment, and it just ignores it. So the next line's a comment. It's a quirk of the SRT control file. The control files must start with a stow command in order for the control file to behave properly, and I should say always. So let's begin with a stow command. There it is. That tells the telescope to stow itself if it's not already stowed. There's a bit of a pain to start with that, because if the telescope's already looking at the source and then you have to stow it and then bring it back to the source, I agree that's annoying, but it's just a bit of a quirk and it's just the safest thing to do. So then we can start recording if we wanted to. Start recording and put in your output file name. So let's call this sun demonstration 2016.rad. The .rad is just the extension that the SRT software uses for the output radio data files. If you don't put it there, the software will put the .rad on the end anyhow. Now we're not calibrating. Remember I said the calibration feature is broken and we don't actually need it. And I actually probably suggest that when you start observing, if you're going to be observing the sun, you should go and observe the sun and look at it at the frequency you actually want to observe it at. You might choose to do it at the H1 emission line, although you're not actually wanting to observe H1 emission from the sun. But you could do it at other frequencies. So if you want to make sure you're not actually picking up any H1 emission, although the sun will be strong, that won't be likely, you could choose other frequencies, for instance 415 megahertz. But I would actually suggest you go and observe the sun, find a frequency that's clear of RFI, because you might find the frequency you want to observe in nominally actually has some RFI, but if you move to a different frequency, there isn't any, or there's little. And that once you've set that frequency in the observing mode, you then go and run the command file. So you probably wouldn't actually want to set the frequency here. In this case, you probably want to go and have a look at the sun, make sure it's clear or your source is clear at the frequency you want to observe. So I'm going to take that out. And as I've said, we're not doing any calibration. All right, so we've said we could start recording and then give a source command and tell the telescope to go and look at the sun. Well, we could do it that way, but that actually seems a bit back to front. So why don't we start with the needed stow command and then tell the software, let's go and look at the sun. And then once we're on the sun, let's start recording. Now we're going to do an azimuth scan. So here's a comment, azimuth scan, start offsets from -30 to 30. In other words, we're going to point at the sun and then we're going to move off in azimuth, that is horizontally, to an offset of -30 degrees. Take one reading, then go to an offset of -28 degrees, take a reading, -26 degrees, take a reading, and so forth, and carry on across. So you would actually need to carry on and continue this, so that this would be -18, 16, 14, and so forth, right through to +30. So you need to type in the rest of the lines there. Let's just do a very short scan, because I just want to demonstrate what's going on. So let's suppose we went from -2 through 0 to +2. Okay, and we'll just call that our azimuth scan. And then we want to do an elevation scan. All right. Now you've got to make sure, because we're going to a plus offset of 30 degrees, if the sun is at an elevation of greater than of 60 degrees or more, then you're going to be telling it to go up. 60 plus 30 is 90 more. So in fact, given that our telescope limits are now about 85, we actually don't want the sun to be at an elevation greater than 50 if you want to go to +30. If it is, the sun is at +65, then just only go to +20. Take those off. So don't drive the telescope into the limit. Okay, very important. So now we're changing elevation rather than the azimuth angle, so it would have plus 30, 28, 26, and so forth, 20. I'm going to do a very small scan and just go +2, -0, and -2. And then we want to finish the recording, turn the recording off, and then for good measure, it's always best at the end of a command file to finish with a stow command. So even if you lost your connection to the telescope, you might lose your internet connection, but the telescope will keep on observing and running the command file. So you'll know that at least, even if you don't get your internet connection back, the telescope will go and stow itself and be put in a safe position. So here we have it. Here's a possible command file. So we'll copy that. Now let's see if we get this to work now. No. Paste. There we are. That's better. Okay. So it's now pasted it into this file. Now we need to save it. So remember that. Do not drive the telescope into its limit at at elevation of 85 degrees. Okay, so we need to save this file. How do we do that? Where do we do that? All right, well, we click the Save button. It's going to say, where do you want to save it? All right, so let's have a look in this place we want to save it is IBM Java 2142. So there it is. So this directory here, let's double click on that and open it up. And we want to put it in here. You could make another directory if you like for your files. Okay, so but I'm just going to save it in here, and to match the name of the file to which I'm going to write, I'm going to call this sun. Oops. Let's just say sun underscore demon. Now let's just call it sun demonstration. I don't have to type. Oh, I'll put it on. Sun demonstration dot, and it's a command file, so it must be .cmd. Okay, so you must put this extension on it. And then we can say we want to character encoding current locale. Yep, that's should be okay. And we can say save. So it must go in that directory in order for the software to find it. So now we can actually go and type this command file name over here. So the command file name is sun underscore demonstration, or demonstration I've actually called it, so make sure I get the spelling correct. Sun underscore demonstration. And click over on this weird button, which, what does RCMD-FL stand for? It stands for Run Command File. You see the CMD is short for command, FL for file. So Run Command File, and it says, okay, you've entered that. I've gone and got the file, and the first line of the file was stow. So I'm going to stow the telescope. Put it back down over here. Get rid of this. That. Just close that down. Okay, so the telescope should be stowing. I don't need this. You can have a look at the camera, and there it goes. Yes, it is stowing. So when we run this command file, it should just go off and do what we want. We're going to assume that we're going to observe it at this frequency. Now, it's interesting that there is actually, in this, appears to be this overall sort of hump shape. It should be flat. I'm suspecting what happens was there was some weak RFI that was giving this a slope in one direction and then another direction, and that overall this is averaged out to that. But when you go and look at the actual data file, some of that should become evident. Fortunately, the sun is such a strong source that these, and for purposes that you're going to be using it when we're doing a scan of the sun, this feature would not be significant. Note that the max minus min is only 16.6 Kelvin. Why are we using Kelvin? How does that make sense? I want to think about brightness temperature, the definition of brightness temperature. No. Okay, well actually let's just keep going through the process. So, of course, when it stows, there's a small spike current that comes up the wire and knocks the camera out. And I've tried putting suppressors on, it didn't work, so the easiest thing is just to restart the software. Okay, and we can see the telescope's already driving now back to the sun. The sun's at an elevation of only, what is that? It's less than 40 degrees, so we can scan up plus 30 degrees if we wanted to, and we can scan down minus 30 degrees without hitting the elevation limits. If the sun's down at 20 degrees, can we go down to an offset of negative 30 degrees in elevation? No, we can't. So you really must think those things ahead. Think it through. What else can we say? Now, the center frequency, remember I didn't set the center frequency in the command file. I'm assuming in that case that I've gone and actually been having a look at the sun, and I have. And, yeah, I'm not actually, that's not perfect. It would be better not to have this hump, but for demonstration purposes, I'll let it run. Now, the actual individual spectra, when we look at them, we're looking very flat, so this isn't too significant, but it would be better if it was just flat across like this. So I might have wanted to choose a different frequency, but for demonstration purposes, I'll just stick with this 1415 megahertz. Note that we're in default mode 1 with a bandwidth of 0.5 megahertz, and then we've got these 64 bins or frequency channels, each 7.81 kilohertz from the next, spanning that 0.5 megahertz bandwidth. We're coming around to the sun again. You'll notice that the geostationary satellites just stay at approximately the same position. Actually, they do actually slightly drift on the sky, because as I said, they're not completely geostationary. But they don't move too much compared to the stars and the sun, which are moving right across overhead. And you remember before that the galactic center wasn't visible, but it's risen now, and it's up at almost 30 degrees elevation. All right, so we're locked onto the sun, and it's telling us it's running these command files, which is to go to an offset in azimuth of -2 degrees. So I don't have to tell it to do an observation. Now, disturbingly, it's reporting a command error. Maybe that command file name was too long. It's actually saying there's been an error. Interesting. Okay, so just while this is carrying on, let's go and check this out. So we can open up the... I'm going to demonstrate something. I'm not actually going to use... That's just your normal filing system. I'm actually going to use a terminal window. Okay, it's already got to the end of file, so it was very quickly able to complete that. And so the last command would have been to stow the dish, and we see that the dish is in fact stowing. But it looks like it didn't record any data in that case, so let's just go and have a look. I'm actually going to use this terminal window. I'm going to change directory to IBM Java 142. And then I want to look at all the files named sun underscore illustration something. There's only one. So I've ever opened that file. I think the file name was too long, because it didn't like the underscores, although that's normally not a problem. Let's just have a look at that file. Command file. Record. Oh. Okay, there are some spaces in here. Okay, so your file name can't have spaces in it, and that was my error. So I could correct that within the terminal using an old-fashioned terminal editor, but I'll go and do it in gedit, just like we did before. So let's open up the text editor. And let's open recently. It's highlighting certain words that it thinks are maybe programming words. It's not sure if this is programming or not. Okay, so take those out, save that, close that. The telescope is stowed. The telescope is stowed. Interestingly, it didn't knock out the camera that time. Nevertheless, I'm going to close it. Let's clear the display. That's stowed. And let's... we've still got the center frequency set to this. That's good. And now let's run the command file. So it's sun underscore demonstration .cmd. We want to run that command file, so we click on that. It says you've entered that. Okay, first line is stow. Done that. Next line is go to the sun. So open up the camera. And off it goes. Here we have it now coming onto the sun, and it's locked on. It then says, all right, the next command is should be to start recording. It's happy with that. We can now see in the bottom left-hand corner that it says I'm recording to this file. The file name is rather overly long, and so it can't show it all there. It's just left this old error message here, just in case we didn't know about it. It's doing the offsets. It's done the azimuth. It's doing the elevation offsets now. So at each offset it takes one reading. And then -2. Turns recording off. End of file as it goes to stow. So we run this command file. Let's have a look at it one last time. Last command was a stow. It's stowing. So that's all worked nicely. So while it's stowing, we can actually now go and get this data file from the computer that we recorded to and bring it over here. So we're going to do a file transfer. And remember, it's in here. It's home. And you can just type this in, srt/IBM Java 142-2. SRT Java 2 142. Sorry. Open that up, and then within here there's this file which was sun underscore. So let's see, which one is it? It's going to be, let's see this, so let's just open this window up. Yeah. There it is, and that's the data file there. Click on that one. If you want to see it name better, you can put it across. Okay, so there's the .rat file. You can see it's tiny. It's only 3.9 kilobytes. And so let's receive that onto my computer, and I'm just stuck it on the desktop of my computer. So we're done. With that. Telescope's now at stow. We've got that little spike, and we could exit the software. And at this point, we could also log out. So how do you disconnect? Well, you just hit this cross up here. And it says, all right, no, you're happy, thank you for playing fair. And yep, we're playing fair. All right, and here's the RAD file over here. Now you can edit that in all sorts of, using all sorts of software. I'm just going to put it into Mathematica and use the Wolfram language to analyze it. So, and I'll do that, my friends, in the next video.